Stanley Park, a green oasis at the most western tip of the Vancouver Peninsula, where city meets the forest and the ocean. The park is an essential green space for all living creatures. Whether you spend a sunny afternoon at one of the park's 3 beautiful beaches, take advantage of one of the many recreational spaces, attend a concert at Malcolm Bowl, or simply walk one of the quiet forest trails, anyone can feel at home in the park. But how did Stanley Park become Stanley Park? The answer: glaciation. During the last ice age, there were 3 major advances and retreats of glaciers that we know of in southwestern British Columbia: the Semiahmoo and the Westland, which occurred more than 60,000 years ago, and the most recent, the Fraser glaciation. These advances and retreats had a major impact on the formation of Vancouver's land surface, including Stanley Park. Giant rivers of ice slowly carved out the North Shore mountain valleys, creating fjords all along the coastline.
Behind me, you can see the Burrard Inlet, one of the many fjords along BC's coastline carved out by the last glacier. Around 25,000 years ago, the Fraser glaciation made its way down from the North Shore Mountains, carving out the landscape that we see today. It was the last major advance of a glacier in the Vancouver area.
Imagine a glacier 2 kilometers taller than the North Shore Mountains and almost 695 school buses wide, sculpting out what we now know today as the Strait of Georgia. At one point, the Fraser glaciation spread out as far as Puget Sound. As glaciers make their journey to the ocean, they carry with them immense amounts of material. The erosion caused by the sheer weight and the movement of these giant ice sheets breaks up the bedrock. This is what's known as glacial till. When a glacier makes its final retreat, the debris that was carried down with it gets deposited, covering the land.
Till carried down from the coast mountains had a typical makeup of sand, silts, and clays, but it also carried boulders. Beneath the forest floors of Stanley Park lies a blanket of sediment, rich in boulders and pebbles, left here from when the last glacier retreated.
All of these different materials make up Vancouver's unique landform. From the rugged and rocky mountains to the lowlands of the shoreline and the sandstone cliffs bordering the beaches, the shoreline experiences constant erosion and is ever-changing.
As the sandstone cliffs around the edges of the park erode from wind and waves, the pebbles and boulders underneath topple down onto the flat shorelines.
During low tide, these pebbles and boulders are visible from the seawall and beaches surrounding the park. These pebbles and boulders give us clues about what kind of terrain was being carved out by these glaciers' slow descent south 25,000 years ago.
Stanley Park's geomorphology is considered to be a cuesta. This term is a specific form of a ridge made of sedimentary rock. The ridge has a steep, exposed face known as an escarpment. The opposite side of the cuesta, known as the dip slope, has a more gradual angle that is less exposed to erosion, making it much different in looks compared to the escarpment.
The cliffs along the Stanley Park seawall geologically are made up of sandstone, mudstone, siltstone, and shale.
The hill is also capped with a thin layer of glacial till clay, cobbles, sandstone, and large erratics. Kinda like this erratic here. Or how about this one? But look at that one. Or this one.
So we're here at the north end of Third Beach. Here we have a large erratic, and in this erratic you can see visible striation lines. These lines were carved into this erratic because it was trapped in the ice in the last glaciation period. You can see these lines are carved and they're all moving in the same direction. And that's because the glacier was moving in the east to west direction.
The rocks that make up the seawall and the wave-cut platform at Ferguson Point are sandstone. This rock is dated at 50 million years old. Over time, the constant ebb and flow of the ocean current mixed with the tiny rocks and sand created the perfect formula to erode the platform. You can visibly see this if you stand on the shore's edge and see the distance of how far the platform extends. Not all rock materials in the cliff, however, are easily erodible. Some of the sandstones are cemented with calcite, giving them more durability from erosion.
Here at Prospect Point is where you find the tallest and steepest cliffs in Stanley Park. These cliffs get their appearance from the vertical cracks, also known as vertical fractures, in their basalt rock.
These fractures cooled and crystallized over thousands of years during a time of molten activity. This cliff face is thought of as an extension of the same igneous rock that caused the formation of the Siwash Rock. Why this cliff is the tallest of the seawall is due to the fact that its basalt makeup is more resistant to the elements than the other sedimentary rocks of the park.
The crown jewel of Stanley Park behind me is Siwash Rock. This rock is a basalt column that was developed when a split in the adjacent sandstone had magma flow through it and pool in the ocean below. Vertical uplift over many, many years had caused the rock to reach the vertical height of what it stands to today.
Over time, the hydraulic forces can also cause the arch of these cliffs to collapse. This makes them a standalone stack or a rocky island. From Prospect Point, there are only tan-colored sandstone cliffs all the way to Siwash Rock. Because of the stability of the basalt rock during World War II, a gun battery was installed on top of this cliff. It is the only gun battery that was installed in the park. The Siwash Rock, or as Coast Salish First Nations call it, Standing Man, is an important figure for the Squamish Nations. According to their legend, a man was transformed into this rock upon becoming a father. It symbolizes his selflessness and immortalizes his story.
The primary soil type found in Stanley Park has a sandy loam texture, with some zones close to the soil surface that become increasingly coarse with gravel and cobbles the further down you go. There are other materials such as silts, clays, and sands that constitute some of the smaller soil types found throughout the park. The glacial till material found around the park is often compacted, and therefore soils have little permeability, usually shallow and poorly drained. Most of the soil in Stanley Park is high weathered due to the amount of rain that the Pacific coastal region receives each year, leaving them rather acidic and low on nutrients such as phosphorus and nitrogen. Some places in the park show significant translocation of iron, manganese, and humic acid from topsoil layers into deeper layers that can be observed. This soil has been classified as humoferric podzol. Podzol is the most common soil in British Columbia, and it is predominant in regions with cool soil temperatures and humid climates. This soil are true tested forested soils found on acidic parent materials. They commonly form in temperate climates due to their relatively coarse parent material and humidity. It provides an ideal environment for coniferous forested ecosystems to pop up. Though opened to the public for recreational purposes since September 7, 1888, the land was originally used by Indigenous peoples for thousands of years before the colonization of British Columbia. The introduction of Stanley Park contributed to the eradication of the Musqueam, the Tsleil-Waututh, and the Squamish cultures in the park. As a result of park road construction in 1887, Existing structures in the Squamish village, Quai, were not spared from being demolished. In addition to the deconstruction of these structures, a majority of the residents in the Quai, as well as other Indigenous residents of the park, were forced out of the area. Today, the 8 totem poles of Stanley Park, situated just off the seawall beside Brockton Point, has become the park's and the province's most visited tourist site. Sadly, they are not representative of the actual Indigenous population of Vancouver, so their presence both erases the existence of the different Coast Salish peoples and constructs an idea of Indigenous cultures as interchangeable. Additionally, the poles are used to reinforce abstract values of inclusion and multiculturalism to benefit the city's image.